Hello everyone and welcome to our presentation. My name is Leila, I'm from University of Sarajevo, and today together with my colleague Aya we are going to present our paper about AR postcards as a learning tool in computer graphics. Our paper is an educational paper about computer graphics course at the University of Sarajevo, and the special feature of this year's final student project is that their projects were integrated into one application called Beha Heritage AR application, and it's about preserving the cultural heritage of our country, Bosnia and Herzegovina. Our country is rich in culture and history, and that's why we think that it is very important to preserve the legacy that was passed on to us. And having that goal in mind, students from the Faculty of Electrical Engineering in Sarajevo created 3D models of cultural heritage buildings, and which they later used in their augmented reality applications. These AR applications and 3D models were created during one semester as a part of the computer graphics course. And not only that they obtained skills about developing an AR application, they also learned an artistic approach to creating and designing an application. So on these slides, you will see some of the best student projects along with the corresponding images of the real objects. Special features of this course is that it's more oriented to creating computer graphics application and less to the graphics algorithms and pure programming. The reason behind such an idea is that because students from the computer science and informatics department at our faculty have plenty of courses about programming, and not so much, they don't have so much opportunity to learn something about 3D modeling, animations, virtual reality, or augmented reality application development.
The students attended lectures which covered the theoretical topics listed here. They also had accompanying tutorials that were done in Blender and Unity. The first part was done in Blender, and it included introduction to Blender and its user interface, object modeling, which included the use of tools for mesh editing, materials and texture mapping, which consisted of creating new materials using various built-in materials, using images as textures and UV editing, and also adding multiple materials to the same object. The next phase was lighting and rendering, which consisted of adding various light sources, the introduction of the three-point light rule, setting the ambience with HDR probes, camera settings, and finally using cycles as the rendering engine. And the objects were exported, and for that we introduced them to simplification by using various modifiers, and the objects were exported into FBX and imported into Unity. The first part of the tutorials in Unity were the introduction to Unity and importing objects and its user interface. And the next was AR development, which consisted of setting up Vuforia engine and image recognition. Scripting in Unity consisted of creating C# scripts that combined certain objects and multimedia content on click. UI in Unity that consisted of adding a canvas with certain objects such as buttons, panels, images, etc., and also scripting the behavior for those elements. And finally, we went over particle systems. The students used the skills acquired during these tutorials for their AR lab project. The AR Lab project was done in certain phases. The first phase was creating the 3D model, modeling it. Then they added the materials and textures, and finally they set up the lights and the camera settings for creating realistic renders in various angles in Blender. After that, they exported the file to Unity and imported it to Unity. We wanted to make an AR application, so we had to create an image target for Vuforia, and we chose to create AR postcards, which are used as the image trackers. After that, we added the 3D main model, points of interest, which are the smaller objects next to the object that are thematically linked to the main object, and finally the UI was created.
Students were marked during this semester at this course through exams, homework, and final project. The final project represented 40% of the students' grade, with 10% going to object renders, 5% to Unity appearance, 5% to Unity user interface, 10% to points of interest and scripting, and 10% for creativity. We think that marking creativity is very important for computer graphics courses, since in that way we can differentiate students that are very talented and dedicated from the ones that just learn the tools and that have no new ideas. And out of 83 students attending this course, in the end, 16 students got a degree 10, 38 9, 25 8, it was 4 7s and no 6 or fails, and passing marks are from 6 to 10. These projects were not only used for passing this course, there were some of the best students' projects were used as for BiH Heritage Augmented Reality application. And in order for application to work, you need to have some kind of a postcard. So you can use a printed postcard, or you can use a postcard on another device. And the application is available on 2 languages, Bosnian and English. And after choosing the language, you are presented with an interactive map of Bosnia and Herzegovina, and you need to choose an object you want to explore more. After choosing that object, you have to scan the corresponding image, after which the 3D model of that object is represented. And on this demo video, you can see some of the objects that are available in our applications, and there are currently 11 available objects across various parts of our country. And if you want to learn more about the object, you can use information button. Along with that, we have a help button where you can see which points of interest there are and which multimedia content they show. For example, if you click on carpet, the image where this 3D model is shown. And if you want to see this application and try it for yourself, you can scan the shown QR code, which will lead you to our landing page, where you can find more information about this application. You can also find the downloadable links. And we are currently have Android application, but soon an iOS application will be available. You can also find AR postcards, which you can print or prepare on another device.
To check if this approach improves the learning about cultural heritage objects, we conducted a user experience evaluation study. This study was done with 17 participants, all engaged by invitation, and the participants were chosen to represent various demographic backgrounds with different genders, IT backgrounds, hardware possession, and age. After they evaluated the application, they filled out the questionnaire with the questions that you can see on this slide. The scale that was used was the 5-point Likert scale, ranging from strongly agree to strongly negative to strongly positive. The results strongly indicate that the use of the BiH Heritage AR application improves the user experience of learning about different cultural heritage objects from Bosnia and Herzegovina. We also wanted to check which of the introduced elements were beneficial and which could be discarded or changed. So if you look at the average scores, you can see that all the introduced elements are beneficial. For example, the addition of points of interest objects helped in immersing the user to the for the user to learn more about the object by presenting the user with various ways in which to interact with the main object, be it by watching a video about the object, reading a text about the history of the object or the people who lived in it or who created it, by hearing audio recordings, or by seeing or scrolling through a gallery of pictures. The information button also added to the learning experience by presenting the information in concise and easily digestible segments. And finally, the help button added to the experience, to the ease of use of the user interface by presenting the POIs and the multimedia content in a easily understood visual aid. So after we did the research, we found three of the results. And the first one is that the students had positive feedback with the project because they not only used it to pass the course, but the projects they made can now be used in the digital cultural heritage preservation of our objects in Bosnia and Herzegovina. Additionally, the interest of the students for the projects, the course, and CG in general, computer graphics in general, increased, and you can see that by the number of good grades that the students had, with 20% of the students having the best grade possible, A's. And in the future, we plan to expand the lab projects and AR applications to different applications in education, such as for biology, mathematics, physics, etc. Thank you for your attention. If you want to check out the application, we have some AR postcards here, so you can try it, be it by downloading the link, downloading with the QR code link, or you can try it with one of our phones. Thank you, and now the Q&A session.
Thank you for great opening of CESCG. When you visit Sarajevo, you realize that if the measure of tolerance in some location in Europe is given by the minimum size of convex hull containing churches for all religions, then the Sarajevo is winner. There is something as big as this castle containing all churches in Europe, and vertically Sarajevo has a very good cultural heritage root and an excellent sensitivity for new technologies. This group is headed by Selma, and Bojan is the first director creating really the 360 degrees movies in this field. So Sarajevo is somehow the touch of our sensing past and future in one, so to say, sensitive point. And this is the time when we can. My first question is implicit. This was evaluated by quantitative method, just questions, answers, and statistics. And this is the time to open the qualitative. You are experts, ask your questions, and people from Sarajevo can continue in evaluating in this new methodology. Now, this is the leading group of experts in Europe judging this contribution. It's your turn. Laszlo?
Okay, so it's beautiful, everything, and I think that the students did a great job with the models, and it takes a lot of work, right, to do all those models. So if you want to extend this to other areas other than cultural heritage, then do you think there is some way to require less human work to create all the models, or is it important that they are somehow created by students?
Only the main objects were created by students, and all the other POIs, which were also 3D models, are just downloaded from free links online. Also, the students could use any of the tools that could help them in creating the models, such as they didn't model the windows all by themselves. They used some built-in tools that Blender already has, and so they didn't spend all the semester just creating the objects. So the whole part of the modeling wasn't that tedious.
Just to end on that, if we wanted to expand this application, we think that it is more important to have 3D models of objects, so we can maybe give jobs to professionals to make them, so we could expand this application because it is more important to have more cultural heritage buildings in our application, so users can experience all of them.
Our faculty does not have the funds for creating such things, so that's why we didn't use that. But if a company wanted to use that, they could certainly do that.
Last question, please.
So at the beginning of the course, students have to write a document about each object where they needed to do research about it and write maybe one paragraph about historical review of that object. But most of the students already know that because it's the object related to their hometown or something like that.
Okay, sorry to say, the other questions and answers I have to postpone for coffee break time. Thank you again.